Why are we going back to wood in the age of steel and concrete? Because modern timber construction is stronger, faster, and smarter than ever before. Traditional stick built methods are being replaced by high tech engineering. Today, we see houses moving from empty ground to a finished home in just a matter of weeks. By leveraging robotic precision and carbon negative materials, the building industry is meeting global housing demands while minimizing its environmental footprint. This is the modern wood revolution. Before breaking ground, builders create a digital twin, a precise BIM model that maps every wire, stud, and pipe. Using AR headsets, planners visualize the building's skeleton before construction begins, allowing them to spot potential conflicts early. This ensures that every component is accounted for in the 3D environment, leading to near-zero error on site. Off-site manufacturing is a game changer. Instead of building on site, 70% of the house is finished in a climate-controlled factory. This factory-first approach allows for robotic precision and avoids the costly weather delays that often plague traditional construction. A solid home begins deep underground. The foundation is the structural anchor that supports the entire weight of the house. First, steel rebar is placed in a grid pattern. This steel provides the tensile strength needed to prevent the foundation from cracking under pressure. Next, high-strength concrete is poured over the reinforcement. While steel handles tension, the concrete provides immense compressive strength, effectively distributing the building's load. This combination of steel and concrete creates a rigid, permanent base capable of supporting the structure for decades to come. The floor system assembly begins by establishing a structural platform directly onto the foundation. This starts with the installation of pressure-treated sill plates, which act as the critical moisture barrier between concrete and wood. With the perimeter secured, we install the floor joists. Modern builds often utilize engineered I-joists or specialized timber, spaced to precisely distribute weight evenly across the entire foundation. This platform creates the stable base necessary for wall framing and ensures a perfectly level surface for the entire structure above. Optimal value engineering, or OVE, is a structural approach that prioritizes efficiency without sacrificing strength. Traditional framing often uses excess wood, which is not only wasteful but also creates thermal bridges. By optimizing stud spacing and eliminating redundant components, OVE saves material costs and drastically improves thermal performance. In this view, we can see the increased spacing between structural members. This wider spacing allows for larger insulation cavities. More insulation means less heat transfer through the walls, creating a much more energy-efficient building envelope. In 2026, raising the walls is a masterpiece of precision engineering. Instead of slow manual framing, we use prefabricated panels, finished off-site with integrated insulation and wiring. Watch as these panels are lifted by crane, descending like pieces of a giant puzzle onto the concrete base. Each connection is calculated to the millimeter. This modular assembly drastically reduces construction time while ensuring perfect structural alignment. This puzzle-fit approach turns months of site chaos into just days of clean, automated installation. Cross-laminated timber, or CLT, is revolutionizing how we build. Think of it as plywood on steroids, a massive, high-performance structural panel. By alternating the grain direction in each layer, we gain immense structural strength, allowing these panels to rival steel and concrete in mid-rise construction. Why swap steel for wood? CLT panels are carbon negative, fire-resistant, and significantly lighter, reducing foundation costs while accelerating construction timelines. As we shift towards sustainable mid-rise buildings, CLT stands as the backbone of the modern timber revolution. The building envelope is the thermal seal of a structure. By integrating high-performance membranes and precision taping, we create an airtight barrier that prevents energy leakage. This membrane eliminates thermal bridging and prevents air movement. Modern taping techniques ensure that even at joints, the envelope remains completely sealed. Without this seal, conditioned air escapes, increasing energy costs. With it, the building retains its climate, drastically improving efficiency. Windows are often the weakest link in a home's thermal envelope. In modern 2026 construction, we treat them as high-performance climate regulators, rather than just openings for light. By using triple-glazed units filled with argon or krypton gas and low-emissivity coatings, we effectively minimize heat transfer between the interior and exterior environments. This technology allows us to maintain a stable indoor climate regardless of outside weather, significantly reducing energy consumption and maximizing natural light intake. With windows properly integrated, our building envelope reaches a near-total thermal seal, preparing the structure for the next stage of systems installation. Now that the structural frame is set, it is time to install the house's life support systems. We call these the veins of the building. First, plumbing lines are routed through the stud bays. Blue pipes carry fresh water, while red pipes handle hot water distribution. Next, electrical wiring is fished through the studs. Modern installers use standardized paths to keep wires organized and protected. Finally, HVC ducts are installed. These channels ensure climate-controlled air reaches every room efficiently. These invisible networks are essential for the comfort and safety of any modern home. In 2026, a home is more than wood and stone. It is a living, thinking machine. During the rough-in stage, we install a digital nervous system alongside standard electrical lines. By integrating sensors for occupancy, air quality, and thermal regulation directly into the frame, AI systems can optimize energy use in real time, drastically reducing waste. This smart wiring approach ensures that even as technology evolves, the backbone of your home is ready for the future. High-efficiency insulation is the key to creating a home that stays comfortable regardless of external weather. We use two primary methods: spray foam and mineral wool. Spray foam expands to fill every crack, creating an airtight thermal envelope that prevents heat loss and moisture buildup. Mineral wool provides exceptional fire resistance and acoustic dampening. Its dense fiber structure creates a stable thermal barrier within the wall cavity. By combining these materials, we ensure our structures exceed modern efficiency standards and maintain thermal consistency throughout the year. Modular upgradability is a game changer in 2026. Instead of static, permanent walls, homes are now built with snap-in panel systems. Each wall is a modular unit. With precision-engineered connections, homeowners can rearrange their layout or integrate new smart home technology without tearing down drywall or structural studs. Upgrading is as simple as swapping a component. This reduces waste and future-proofs your living space. Internal conduits are pre-wired into these panels, allowing for quick sensor or hardware upgrades. Your home evolves as fast as the technology inside it. A life cycle assessment, or LCA, is a rigorous process that calculates the total environmental footprint of a building project. It is now a standard requirement for modern construction. Builders track every stage of material life, from the carbon absorbed during forest growth to the energy used in extraction, transportation, and eventual disassembly. This ensures that the carbon locked into sustainable timber outweighs the carbon emitted during construction, meeting strict environmental compliance. By using life cycle assessments, we ensure that our built environment supports global sustainability goals, locking carbon away for decades to come. The final step is the comprehensive inspection and certification process. We verify the house's tightness using a blower door test. By creating a pressure differential, we measure air tightness in air changes per hour. Today's strict efficiency codes demand minimal energy leakage. A reading of 0.6 air changes per hour is a hallmark of high-performance construction. Once cleared, the home is officially certified as safe, efficient, and ready for occupancy. We are entering a new era where wood is no longer just for cottages. Mass timber engineering now allows us to reach skyscraper heights. Simultaneously, modular microhomes are transforming urban living with plug-and-play efficiency. These trends point toward a future of sustainable, upgradable, and incredibly fast urban development.